let's calculate something. Today we're going to study the laws of exponents, and what we're going to do is go through each one, and we'll have like a sample problem and an example, and then we'll have you guys try some problems on your own. You can pause the video, I'll give you the answers and explanation for all those problems, and then also I'll give you some homework at the end. Now, what we're going to do is first we're going to study the product rule and the quotient rule. Then we're going to study the power of a product rule, then the power of a quotient rule, and then we have these two, which we'll cover later. So, with the product rule, when you multiply two exponents with the same base, you add the exponents for the final solution. With the quotient rule, when you divide two exponents with the same base, you subtract the exponents and then keep the same base. With the product rule, when you raise, so this is the power of a product rule, I'm sorry. When you raise an exponent to another power, you simply multiply the powers. And then, with the power of a quotient rule, whenever you have two exponents that are raised to a power, then it's equal to the quotient of each exponent to that same power. Okay, so let's cover these first four rules with a few examples. I've prepared some up here. Whenever you have a problem like this where you have to do some simplification, you have to think back, and once you understand these rules, it'll become second nature. It'll be pretty quick. So for this case, we have x to the fifth times x to the seventh, and we need to figure out how to simplify that. So which rule do you think we would apply? I think we would apply the product rule. Since we're multiplying two things together, we'll apply the product rule, and we will then simply say x, add the two exponents to the seventh. So that's the first one. Now this one's a little more complicated because we have some more terms, but we apply the product rule in the same way. You just work by exponent, exponent based on the base, okay? So here we have AA, we're gonna multiply those together, and what are we gonna do? We're gonna add the exponents. So we have A cubed. With B, we have B cubed times B squared, so that would be B to the fifth. And then we also have this C term. And really, we don't have a C over here. So we would write C to the fifth, okay? Now, what would come into play here is this rule, actually, okay? Because A to the 0 equals 1. So really, we could imagine that over here, you could imagine that we have a C to the 0, okay? And that is 1, so, okay? And then when you add 0 and 5, you keep the same thing. So there's a special case, a special example to kind of reinforce this zero exponent rule. Okay, so let me put up a couple more examples and we'll work a couple more problems. Welcome back. Okay, so now if we look at this expression, when we see the dividing sign, right, we see the divisor here, we automatically know we're going to look at the quotient rule. What does the quotient rule say? It says when you divide two exponents of the same base, you subtract those exponents, okay? So for this one, we have a whole number, we have a value of x, and we have a value of y. So we just walk through the problem one at a time. So 3 into 36 is 12. And then x to the fourth minus x, which is x to the 1, would be x cubed. And then y to the fifth minus y, which is y to the 1, would be y to the fourth. Okay, so that was using the quotient rule. Now we are going to use the power of the product rule and the quotient rule. And this is where it gets a little bit trickier, because what we have to do is use the order of operations. We have parentheses here. We have something raised to a power. So in simplifying this, first we have to simplify this piece. And to do that, we're going to use our power of a product rule on this. Then we're going to take that result and we're going to use the quotient rule, like we just did up here. So this is the same problem as up here, but by squaring this term, I wanted to show you how this changes, okay? So let's do that. So this is going to equal, we have to square every term in here based on the power of the product rule. So we have 36 x to the 4th, y to the 5th, divided by 9 x squared, y squared. Right? Because we're going to multiply the squared term times the 1 and the squared term times the 1. So you get this. And then we're going to square 3. Now we're going to operate on the quotient rule. So 9 into 36 is 4. Okay? X to the 4th divided by x squared would be x to the 4th minus x squared, which would be x squared. And y to the 5th divided by y squared would be y. 5 minus 2 is 3. Y cubed. So this would be the answer for the second problem. And you can see it's quite different than the first problem. But it makes a lot of sense because we squared the 3. Okay, that became 9. We divide 9 into 36. We get 4. And then we squared this, so we're going to drop one layer on this one, right? So it's 2 where it was 3 and 3 where it was 4. So it kind of makes sense how this works out, but that's an example of where you have to combine some of these rules. First we did the quotient rule, then we did the power of the product rule, and then applied the quotient rule. And it's important to remember your order of operations. You got to simplify this first, then do your division. Okay? I'll put up a couple more and we'll try some more. Okay, so now I have 4 problems for us to work through, and then I'm going to give you some to try. So let's work through these. So we have this one here, and again we have something in parentheses squared. So which rule do you think it is? I would say it's the power of a product rule. So in this case, we will multiply 2 times the exponent, which is here, which is a 1, and we get x squared. And then we have y to the minus 6 squared, multiply that, and it will be y to the minus 12. Now, you could see this answer because if we look at the negative exponent rule here, when you see a to the minus m, you could also write it as 1 over a to the m. So this would be equal to x squared over y to the 12th. These are exactly equivalent, okay? And that would be using the negative exponent rule, okay? So let's go on to the next one. The next one is, here we have x and x, so we have a common base. We have x to the 7th, but it's raised, it's cubed. This part is not cubed. So first we have to do this, right? We have to follow the order of operations. So we get x to the 22 times x, 3 times 7, using the power of a product rule, is 21. And then we have to combine these two using the product rule. We get x to the 43. Okay? So again, you got to watch for these rules to start combining themselves, and you have to figure out what order to go in. Okay? Here we have a quotient rule. You could tell right away we're going to use the quotient rule, one of them, right? But we also have this piece here raised to the minus 3 power. So we have to use the power of a product rule first. So that would be q to the minus 12th divided by q to the minus 15th. Now, which rule do you think we're going to use here? Yes, we're going to use the quotient rule. So now what we have to do is we have to do q to the minus 12 minus a minus 15, which is really plus 15. So that's going to equal q cubed. Okay? So there's a case where we had to use 2 rules, but we could just walk through, and when you subtract the minus, you know you're going to add. Now here's an interesting one. Here we have 4 terms, okay? We have 4 terms, and we have some funky things because we have these minuses in the bottom of the equation, right? So we're going to get a, this is all quotient rule, we're going to get a to the 1 minus a minus 1, which would be squared, times b squared minus a minus 2, which is b plus 2, so that's b to the 4th, c cubed times c to the minus 3, or divided by c to the minus 3 is minus a minus 3, so that's c to the 6th. And then d to the 4th divided by d to the minus 4th, so we take 4, we subtract a minus 4, that's like adding a 4, so we get d to the 8th. Okay, so now you've seen a number of examples. You can go back and review those examples if you like, but what I'm going to do is put up 4 problems for you here. Once you get back, then I want you to look at those problems, and then I'd like you to solve them, and I'll give you an amount of time to solve them, because if you're on an exam, you're going to want to do those quickly. So you should have a certain amount of time. It'll be more important for you to get them accurate than it is to get them right than it is to get them quick. But if you can get them right and quick, it'll be great. So let me set those up, and then we'll do that little quiz. Okay? I'll be right back. So here we have 4 problems, and they vary in intensity and difficulty, and in which rules they're going to apply. And some have a combination of rules. So what I think is if you can do these in 2 minutes and get them all right, you got the concept, you're doing awesome. If it takes a little longer, it's okay. That means you need more practice. If you miss some of them, that's okay, because I'm going to go through all of them at the beginning here. I'll put the answers up. And if you've got them all, you can skip to the next section, and I'll put the time up here so you know when that is. But I'd like you to give it a try. Let's pause the video so that you can keep these problems up. Get a piece of paper, write them down, use your phone or something to do some time, and try to get them done in 2 minutes, okay? Go. Okay, hope you did well on those. If you got them in 2 minutes, here's the answers. Take a little time to check your answers against mine. I think if you got them all right, then you can skip to this portion of the video, go to the next section. If you missed one, I'm going to walk through each one right now, and you can one or more, and then you can see how they're solved. So the first one is x cubed times x to the minus 12th. This is the product rule. We add the exponents. 3 plus minus 12 is minus 9, x to the minus 9th. This one here is a little weird. You got this 14 divided by 8. We can't really divide it out, but we can simplify it to 7 over 4. So that's what we do. A to the 4th divided by, this is all a quotient rule. A to the 4th subtracting a minus 2 gives us a to the 6th. The 6 minus 3 gives us b cubed. And the minus 10 and the minus 5, that means we add 5 here. So we subtract a minus 5, that's adding 5, that becomes c to the minus 5th. This one here, we have two of them that require us to use the power of a product rule. So we have to take the 49, the 7 and square it, and then the x cubed and square it. That gives us x to the 6th, we multiply. Then x to the 8th multiplied by the 1/2, that's x to the 4th. Then we combine these with the product rule, and we get 49x to the 10th. This one is a little tricky. This one here, you may have gotten close to the right answer, but you may have forgot something. So 144 to the 1/2 is basically this here. We take the half times 1. We end up with that. K squared times a half gives us k. And r to the 14th times a half, 14 times the half is r to the 7th. And then really this is 1/2 is the square root of 144. And technically, it should be plus or minus 12. But if you just saw plus 12, that would be correct too. But just wouldn't be complete. So those are the 4. Hope you did well. Hope you got them all right. And now what I'm going to do is 3 or a couple more challenging problems, and then I'll put up the homework. Okay, so this is a pretty challenging problem, really, because it combines basically, when you look at this one, you see the quotients, you see the multiplication, you see a power raised to another power, you see the -5 in the denominator. So this one is pretty messy, and it's going to require us to use all 4 of these rules in one problem. Okay, so where do you think we should start? We talked about it earlier. We've got to start here. So we have to get this part figured out first. That's number 1. And then I like to work across the denominator and then work across the numerator. You could also work on this side first, do it this way, or you could multiply first. I prefer to do division one time, and I think it's a little faster, so that's why I'm going to work across and then divide. Okay, so that's going to be number 1 here. Let's figure out that. So this is going to, and you can do this on the test, you can quickly mark these things. So we're going to do it, we're going to take a shortcut. This is now a 12. Okay, and if we look across here, we have 10 times 4, so that's 40. And we have q to the 5th times q to the 12th, that's q to the 60th, right? We're going to add the, no, it's not q to the 60th, that's my bad. It's q to the 17th. Okay, we're going to add the exponents. And then the w just stays over there as w to the 7th. Now we're going to work the bottom. Okay, so 2 times is just going to carry across. W cubed times w to the -5th. We're going to add the exponents. We get w to the -2. Okay, now we can simplify this. All right, and so we can see this goes into this to 20. Okay, so now we have 20 up here. Just do that way. Now we have q to the 17th. There's nothing in the numerator, but we have to take this 2 and bring it up here, so we can cross this out, and we can just add 2 to this, which is a -2, which is +2, and that becomes the 9th. So now you have 20 q to the 17th w to the 9th, and you got it. So I did it this way, the shorthand way, only so that you can get speed for your test and you can see this and quickly simplify it, because this is going to become second nature. So what we did is we got rid of the first part first. We had to identify, whenever you have the power of a product, you got to do that first, or the power of a quotient, you got to do that first. Get that done. I worked across, and I only had to do the division once, because division's a little harder because you're subtracting. Subtracting is harder than adding. So that's how we did it. That's the first example, the most complex we've done so far. So there you go, you have that one, and I will go on to the next one. Okay, so this is kind of a fun problem. It's a geometry problem using exponents. So if we know the area of this rectangle is 54x to the 9th times y to the 8th, and we know the base of the rectangle is 6x cubed y to the 4th, how do we find the width? Well, we know that the area of a rectangle equals the base times the width, right? We have the area and we have the base, so we can solve for the width. We have to do a division, and we can use the quotient rule to help us figure out what the w will be. So let's solve that. 54 x to the 9th y to the 8th equals 6x cubed y to the 4th times w, which is this here. Okay? So now we have to divide this over. So 54 divided by 6 is 9. X to the 9th divided by x cubed, which would be x to the 6th, because we subtract 9 minus 3. And then y to the 8th minus y to the 4th is y to the 4th. We subtract 4 from 8, and that equals w. So that would be our answer for this problem. And we basically used some geometry, we used the quotient rule, and we were able to solve that problem. Okay? So we have another geometry problem. In this case, we have a circle with radius 6x to the 9th, y to the 5th, and we need to find the area. So we know the area of a circle is pi r squared, and r is 6x to the 9th, y to the 5th. So in this case, we can use the power of a product rule, because we're going to square this term, multiply it by pi, and we should get our area. So let's try it. So a equals pi times 6x to the 9th, y to the 5th squared. So in this case, we have to multiply every term by 2. So we have a equals, we'll take this over here, 36. Okay, we have to square this one, 36. And then we have pi. Then we're going to have x to the 18th and y to the 10th. And that's our answer. So in this case, we multiplied through and we squared every term. So we squared x to the 9th, we get x to the 18th. We squared y to the 5th, we got y to the 10th. We squared 6 and got 36. And don't forget the pi. Okay, so that's it. Welcome back. Okay, this is the last section of the video. We've got 5 homework problems. You'll be using all the rules for these, and I'd like you to try to do them in 7 minutes. And these 2 are particularly challenging. This one's kind of challenging, that's why it's in black. This one's super challenging, that's why it's in red. If you can do all these problems in 7 minutes, you got it. That's going to be really a good you're in a great shape. You've got all that you need to know about laws of exponents. If you can't get them that way, then you're going to need to practice some more. But what I'd like you to do is put your answer in the comments for all 5. And then what I'll do after I see some people put some answers in the comments, then I'll give the solutions for these 5. Okay? I hope you enjoyed the video. Please subscribe to our channel. We have a lot of videos coming out. Hit the notification bell and you'll be aware of when those come up. And then also, if you can leave some comments like your answers, and then additional comments on feedback, and then finally, if you can like the video, if you got something out of it, that'd help the channel too. All right, thank you, and we'll see you next time.